solve an answer in a graph and interval form the rational inequality. Rational inequality, that means fractional. X plus 3 over x squared minus 1 is greater than or equal to 0. Okay, first we're going to set the top equal to, well, before we do anything, we should factor wherever we can factor. So the top doesn't factor, but the bottom does. So we have x plus 3 on the top, x plus 1 times x minus 1 in the factored form of the bottom is greater than or equal to 0. That's our step 2. Now let's set the top equal to 0. The top is x plus 3, set it equal to 0 and solve for our critical number. It equals, let's see, x is equal to negative 3. Now set the bottom equal to 0. X squared minus 1 equals 0, so x squared is equal to a positive 1, and x is equal to plus or minus the square root of 1, which is plus or minus 1. So we've got 3 critical numbers. We're going to take a number line, that's an x-axis, and we're going to partition it using negative 3, then negative 1, then 1. We're putting them in order of magnitude. And then we're going to write the factored form of the rational expression x plus 3 over x plus 1 times x minus 1, and find the sign in each of the 1, 2, 3, 4 regions, the sign of the factors. Okay, so we're going to have to choose a value for x in each region. The first region is a value smaller than negative 3, like negative 100 for x. That gives us a negative on the top for the first factor. Are we ready? Okay. In the left region, a negative on top, a negative, and another negative on the bottom. When we let x equal negative 100, gives us a negative result. When we multiply the bottom, we get positive. And then we get a positive result for the quotient in the next one. For the next one, we get a negative result. And then in the last region, we'll let x equal 100, we get a positive result. Now, it looks like they're alternating. I wouldn't count on that always happening. I would always check with a sign graph to make sure. Show your sign graph, show your work. Okay, so over here we're looking at now the step 2 where the star is. The inequality said greater than or equal to 0. To be greater than or equal to 0 means you're positive. So we're just going to shade the regions that made the quotient, that's the result of the fraction, makes it positive. That would be the second region right here where I'm highlighting, and the fourth region. So shade all of that. Now let's consider the endpoints. Let's see. We have greater than or equal in the original question, which means that we include our endpoints except any endpoints that make the bottom 0. Well, plus or minus 1 is going to make the bottom 0. I can see that in its factored form. So those values are not going to be included. They're going to get round brackets. So let's see what this thing looks like. Between negative 3 and negative 1, round brackets on the negative 3 and the negative 1, and shading in between, and then a round bracket on 1 and an arrow on the right side of that. So our conclusion is this picture. Here's an x-axis. Boxy, we included negative 3. That was included because it didn't give us a 0 denominator. So boxy bracket, I was mistaken. Boxy bracket on the negative 3, round brackets on the other numbers, negative 1, positive 1. And then describe each of those intervals. Like the first interval, it is the smallest value shaded is negative 3, comma, the largest value shaded is positive 1. Include the negative 3 with a boxy bracket, exclude the negative 1 with the round bracket, then union together the next interval described by smallest value shaded is 1, comma, largest value shaded is infinity. Exclude 1 because it gives you a 0 denominator, put a round bracket on it. Always exclude infinity with a round bracket, and we're finished.